Hi, everyone. I've been told I'm live, so I'm just going to start talking. I'm Jean, and today I'm going to talk about how automatically generated API specs are going to be a game changer for dev tools and what we're doing at my company, Akita Software, to make that happen. And if you haven't already noticed, this is a live talk. I will be checking the questions in the chat periodically. So if there's anything that doesn't make sense or that you just want to know, feel free to ask in the chat and I will try to address all of it either as I go or at the end. All right, cool. So you're probably at this conference because you've been sold the dream of APIs. On the consumer side, it's basically getting delivered breakfast in bed. On the producer side, it's getting this steady stream of fame and fortune. But you're probably at this talk because you've also felt the pain of the reality of APIs. It's not easy for API consumers because anybody can take you down. And it's not easy for API producers because you can take anybody else down. And so this talk is about how to un-Jenga your software systems. And it's also an argument for why developers should like API specs more. So I'll start by talking about current heroic efforts for keeping order with APIs. It's really not easy for developers today to make sure everything with APIs, either APIs they use or APIs other people are using of theirs. Why APIs are hard to manage. My take on it is it's because it's APIs all the way down, and I'll talk about what that means. And then I'll talk about, this is a bit of a spoiler alert, but automatically generated API specs are going to get us out of this mess. And I'll talk about what we're doing at Akita, and I'll give a quick demo of what we're doing here. And before I begin to convince you to listen to the next 20 some minutes of this talk, I'll just introduce myself a little bit. I'm Jean. I come from mostly an academic background, so I fell in love with programming tools in college. I went to grad school for programming tools. I was previously an assistant professor at Carnegie Mellon University in the Principles of Programming group. I was on the types, formal verification, those kind of specification side for a very long time. I was publishing in places like the International Conference of Functional Programming. But the whole time I saw this pretty big disconnect with what was happening in web programming today. So on the one hand, you had these beautiful ways of supporting programmers. And on the other hand, you have what web programming is today. And I just felt like what I was doing in academia wasn't solving the web programming problem. I came to believe that we need tools at the API level, and the API level is the right place to be working on this. So in 2018, I took a leave, I sold all my furniture, I drove across the country, and I started Akita. And that's what I've been working on ever since. And I picked this picture because it turns out I actually am really into Sriracha. So here's just a quick glimpse into the setup where I'm giving this talk from. And I had posted this because I'm definitely not like a look at my setup, here's my live streaming setup kind of person, but I just accidentally acquired all of this paraphernalia. And when I posted this photo on Twitter, the one thing people noticed was the bottle of Sriracha, which I am very serious about. So yeah, that's me. And let's get started with talking about the current heroic efforts for keeping order with APIs. Long story short, it's real hard these days. So I'll start with a case study, which is a blog post from Shopify. I'm going to pick on them because they have this great blog post that I can reference in these slides about how they do impact analysis. So like many of you who have APIs that other people use, they have this mantra: we break the API contract with the ecosystem only when there are no alternatives or it's uneconomical to do otherwise. And in order to do this, something called impact analysis becomes very important because you have to know how any code change might lead to an API change. And so some of the talks yesterday that I attended talk about this Shopify blog post also talks very nicely about this. And how they do it at Shopify is they have this API change module where they have these annotations, mark breaking, mark possibly breaking. And what they do is they have developers annotate code with this. They have an engine that spits out context, so it spits out metadata to help track this. And then they consume consume this metadata to generate reports of whenever there's a possible API change, this is what it could affect. And if the effects are very big, they actually will have their DevRel team go out and talk to the ecosystem users to make sure it's not so bad. And so I picked out this example for a couple of reasons. One is I loved how principled they were and how disciplined they were. But the second is it is really a lot of work to do things this way. And here's why. It's because any code change can be a breaking change. And so unless your external API is really not impacted by a lot of your code, there is a lot of stuff that you are trying to track. And so from the Shopify blog, things like changing existing error response codes, modifying the expected payload of webhooks and callbacks, changing the type of a data field, renaming a field, all of these can lead to changes. And when your software is this kind of system where you have many interacting components and anything in one place could affect things in other places, this is when this mark-breaking kind of system starts becoming quite intense. And so I love what Shopify is doing, but a point I'd like to make is this stuff is not easy. And it's not that developers can't do this, but it's that if we have these systems where developers have to do mark breaking, they have to do this analysis, they end up having to do manual work over and over again. And if there's one thing we know in software engineering, it's that asking developers to do the same thing over and over again is error prone. And so as a programming tools person, my take is we gotta have better tools for this. And so at this point, you may or may not be wondering, why aren't the existing tools good enough? So from my perspective as a programming languages, program analysis person, here's what's going on. So there are a few ways that people think about the source of truth in their programs. There's source code, there's tests, and there's analyses you can do on your software. So diffing source code. So I did a survey on my Twitter account. About 800 some people responded recently about what's the source of truth. Almost 70% of the respondents said source code is still the source of truth. It's, when they do code reviews, this is what happens. But in these kinds of systems, if we think about something like API change impact analysis, diffing source code is not going to give you the whole picture. And so first of all, the size of the code has just gotten really big. And so even for very small source code examples, I'm sure you can all come up with situations where there are subtle interactions and just reading the source code will cause your head to explode. But at the sheer size of code bases today, diffing source code is just not going to tell you about, how this code is going to interact with all the libraries, all the other code that it's supposed to fit in with. And so that is not really going to be your number one tool for impact analysis for a really complex software system that has an API. And so, all right, so source code is not an existing tool that's solving the whole problem. What about tests? If we think about the kinds of things that you look for in an impact analysis, like error codes changing or the payload having a different value, I don't know about you, but I've never been in an org where tests so thoroughly tested every single interaction that I was guaranteed to catch this. So tests are great. Tests are important to have, but relying on tests to cover all of these potentially breaking interactions in an impact analysis is also not going to cut it. And so now we bring in something that I'm very familiar with from my background, which is automated software analysis tools. So usually people bring these in when reading the code is not scaling, when tests alone are not scaling. So here I'm talking about things like static analysis, dynamic analysis, fuzzing. And these are usually great because there's some model of the software that an automated tool can consume, and then they can check against that model to see if everything is good. And so there have been immense advances in static and dynamic analysis in the last couple of decades. But the problem is they completely fall down when there are black boxes. So anytime you call a SaaS API, that's a black box. That's not inside your model. Existing analyses do very poorly with that. And similarly with network calls. So in a lot of places where people are modeling systems using static analysis for checking, the minute you do a network call, that subverts all of your guarantees. Everything goes out the window. You have to make the most conservative of assumptions. And so existing tools, they were really made for when code was small, when code wasn't calling other code across the network all the time. And so essentially what's happened is advances in API use and service-oriented architectures have just caused modern web apps to outgrow all of this power tooling. And so the dream, in my opinion, is automated software tools that actually fit modern web apps. And so I'll talk a little bit about how to break this down and how we're going about solving this problem. But there are many facets to this problem, so I'm laying out the dream so that everybody else can work with us on solving it. All right. So to summarize API efforts in the present day, and this echoes a lot of what I've been hearing in other talks, is that if you have an external API and you're at a company with the resources to spend on tooling, so your Shopify's, your Stripe, your Twilios of the world, then you get love on your external API. You get the nice frameworks that will automatically generate your API specs. You get the nice change impact analysis that takes developer work, but at least you have it. And everybody else is left in an empty parking lot with weeds growing out of the pavement. And it's not really anybody's fault, but it's that the tools are really behind where the systems are today. And so in the rest of this talk, I'll talk about what this means and how we can address it. I'll just check really quickly to see if anyone has any comments in the chat. If I can open the chat. All right, cool. So I will keep going. There's an HD button somewhere. I don't see it, so sorry about the slide resolution. Hopefully it's okay. All right, so now let's talk about what's hard about managing APIs. And my take on it is APIs are hard to manage because it's APIs all the way down. And I'll talk about what that means. So more and more of software is APIs these days. From this rapid API developer survey, we have this nice up and to the right graph about how as your organization grows, the number of internal APIs you have at the company is grows with the size of the company. And so you might just have a fixed number of external APIs, but you sure have a whole lot more internal APIs. And in the limit, everybody loves to use the Death Star pictures, but in the limit, you have the Death Star. And I'll talk a little bit in a little bit about what this has to do with API specs. But first, let me get to the heart of what I believe is gumming things up. And I'll start by going back to what I said before, which is it's really hard to model software once you leave a single application layer. And here's what I mean by this. So if we go back and we think about the API graph and we think about one edge of the graph, here's what it takes to model that. So here's a screenshot of a paper that I published in 2016. You don't have to understand this paper to understand the point I'm making on this slide, but I'm putting it up to make a point, which is that it's really hard to model across one edge. So the story is I was making a domain-specific language for analyzing code for data leaks. I prototyped it. I started building a web app using it. And what I realized very early on was as soon as I called out to the database, my web app did not have any of the guarantees from my application layer anymore. And so same with what I was saying with when you have black box, when you have network calls, anytime you call out to a different component, it's just all of the automated modeling techniques don't actually work anymore. And so I was like, all right, I've got this thing. I'm modeling it in the application layer. It was in a Python embedded DSL. I'll just really quickly extend my model to a SQL database, and then we're good from there. And so I was right in some sense about the quickness of it and that it was one page of Greek symbols here to do the modeling. What I was wrong about was it took 3 years to actually figure out how to extend the analysis to the database. And so again, you don't have to understand anything from this slide, but my point is, it took 3 years to take an automated analysis at the application layer and extend it to one kind of database. And so you can imagine the despair that I went through during grad school when I thought about all of the heterogeneous components of a modern web app and how many edges of this graph we would actually have to model and how many years that would add up to. And so to me, I had kind of a choice. I could either spend the rest of my career modeling every single edge of modern web apps, or I could take a different approach. And I went with a different approach. And so how I summarize this problem is I call it the software heterogeneity problem. And so to me, this is the heart of why it's so hard to scale your automated software analyses to things like impact analysis and modern apps. Analyzing modern web apps is hard because, first of all, there are just many, many software components. And so there are pretty great analyses for if you just have, a single program in itself. But like I said before, the minute you have something black box, the minute you call over the network, and the thing that's really jamming things up here is the fact that you're calling things over the network that are different from yourself. Because if you're just like a Python program calling a Python program, there are ways to pretend that's just one big Python program. If you're a Python program calling a database, your Python program calling a data stream, like that is heterogeneous now. And this is completely defying existing application level solutions. And it's also defying existing network level solutions. So if you think about all of your power tools at the application level, things like your static analysis, dynamic analysis, linters, things like that, like they don't help you when you call across the network. And anything that lives across the edge, your network tools, your API tools, your WAFs, your RASPs, those are only handling one edge at a time. Nothing is helping you analyze this entire graph. And so as a result, developers today do a lot of manual work. We've been talking a lot about this work at this conference so far, but it's expensive to keep API documentation up to date. It's expensive to understand the impact of code changes, and it's expensive to understand the impact of other people's code changes onto you. And so now I'll talk about how automatically generated API specs will get us out of this mess, and I'll demo what we've been working on so far. And so if we want to model heterogeneous web apps and automate some of the work that developers are doing manually, here's what we need. We need a more homogeneous way to describe each component of a modern web system. We need a common specification for how to talk about how these components interact. And we need a way to connect the specification to the code. So I already gave this away, but as Taylor Swift once said, been here all along, so why can't you see you belong with me? This could also be said by API specs, because API specs are really the perfect thing that satisfies all of this criteria. So the insight that we had at Akita was, well, we should be analyzing API specs and API traces, not programs and program traces. But if you've attended any other talk in this conference, you'll know that API documentation is not so easy to come by. Only 35% of API providers feel that their organization's documentation is above average. For context, it's something like 100% of parents surveyed feel that their children are above average, and that's just not possible based on how average works. And so this means the state of API docs is pretty bad. And there's a reason no one's been using API specs for analysis before, which is that it's pretty manual today to actually get specs. So Postman and Insomnia are awesome tools. They help with recording and sharing API endpoint information once you have it. But there's still a great deal of information that the programmer needs to have, and there's a great deal of work the programmer needs to do in order to get there. And then there are libraries and specialized frameworks for automatically generating specs, but those are not the norm, and those also take work. And so to us, the challenge that we posed for ourselves was how can we automatically generate API specs with as little developer effort as possible? So what we want to do is generate API specs automatically tied with the code. So on every pull request, we don't want any code or config changes, or we want to keep it to a minimum. So we didn't want any kind of special library or special configuration. So we just wanted to be able to drop something in, start generating API specs, and then start doing all kinds of really cool analyses from there. And so our big revelation was everything that we've been working on in programming languages at the application level, we can now apply it to API specs. So things like invariant generation, trace-based analysis, type inference, automated testing. There's been decades of work on how to apply all of these to application level programs. What we're doing now at Akita is applying it to the API level for generating specs, for giving you analysis on those specs. So what we do for you at Akita is we give you a handle on what we call the API graph. So the baseline is we automatically generate API specs for you. I'll demo that, so I won't talk very much about it now. Once you have API specs, it is magic for improving code quality. So we can do regressions for you across your pull requests. We can diff your production API spec with your test API spec to figure out, like, how's your test coverage? How are you doing with your assumptions about what people actually do? And then we can also diff the spec we generated with the spec you wrote. So for everyone doing design first, we can tell you if your designs are actually coming true. And something that I'm really excited about is that this is powered by, super cutting edge programming language technology. But whereas previously, in order to use a static analysis or a fuzzer, it's like, weeks, if not quarters of configuration, specification, integration work. For here for us, we want to make it so that if you have an API spec, you can just use our tools immediately. So I'm going to give a demo of what that means. I don't have a ton of time left, so I'll go through this pretty quickly, and then we'll get to questions. But we're just going to generate an API spec. Then I'm going to show you all of the analyses we're able to do so far. And we're still pretty early in our product process. We're in a private beta. And so something that we would love, if you're interested, is join our private beta. Tell us what kind of analyses you would like to see us do. And then I'll show you what it looks like to be integrated with GitHub so that we are detecting issues on a pull request basis. All right, cool. So what I'm going to do, and if you onboarded onto Akita, this is what it would look like, for you immediately. I'm going to put up, I'm going to throw up a quick service. And so this is something called AkiBox. It's a little test service. It's like a mini box or Dropbox. It talks to Redis. I'm going to talk to Akita from it. So here it just sets up Akita to listen to the traffic. I'm going to run some tests, make some users, make some folders, make some files. And as easy as that, we have collected some traffic and we can generate an API spec. So now let me go to Chrome. All right, so when I generate an API spec, what I want to know is, what are my endpoints? What data am I sending around? Where might I have sensitive data? And what else do I want to know? And so here, the things that I just did automatically generated this open API spec. We integrated with Redocly, so you can explore it. Here are my endpoints, and here's more information. Something cool I'd like to point out is we have actually some super powered spec type inference. So we're able to detect not just that it's a string, but this is an email. And so when we diff on that, we're actually able to give you very fine grained alerting on when this changes. And then we're also able to tell you types that are seen together. So if you have a user type that's being passed around a lot, or if you have some kind of type that's being produced and consumed by pairs of API calls, we also catch that. We get not just inbound, but also outbound. And so we're able to not just document your endpoint, but give you a little more information about the endpoints you're talking to. And these things can be a lot of text. So we started collapsing this into insights. So we give you a summary of your data formats. We highlight what sensitive data formats are there. We tell you about your request parameters, response parameters, and your status codes. And we have this for not just inbound, but also outbound. And all of this we can diff on. And so I'm running pretty short on time, so I will very quickly show you what it looks like to integrate with your CI. So I'm going to add an endpoint to this new branch that I made. And then we're going to try checking it in and see the report that we get. So I'm going to stage my changes. I'm going to commit this, added an endpoint. And then we're going to make a pull request. And so what you should see after this is Akita will actually alert you there's been a new endpoint, and we're actually sending phone numbers through. So it will alert you on that as well. So this will take a couple of minutes. What I'm going to do is go back and put up a slide that tells you how Akita is working while I see if there are any questions. So if you guys have questions, feel free to ask them right now. Someone asked how this compares to Optic. That is a great question. So it's my understanding that Optic works if you have open tracing installed already. So their instrumentation piggybacks onto open tracing. The really cool thing about us is that if you see from this diagram, we don't have to integrate with any kind of a code framework. So all you have to do is set up your client, let the Akita client observe your traffic. We don't even send sensitive data back to ourselves. So we just send the metadata of your requests and responses, and then we generate the reports. And then you can integrate this in your test. You can integrate this in your production. You can integrate it anywhere. And so here we're still waiting for this. This should come soon. Let's refresh to see if it's there. Okay, it's still building, but yeah. So you should be able to very easily, like the thing that I demoed when we onboard users. That's like exactly what you do. You drop us in, and you can start using us right away. And somebody else said, do you foresee this sitting in production traffic scenarios, or is it best to use in pre-prod? So there are use cases for both. So I'll just put up this last slide to help answer that question. So the way we see it is once you have automated API specs, you can use this to diff across your pull request. So that's for pre-prod. Initially, that was our intended use case, but a bunch of our users said, can I just put you in prod and then diff this against my spec in my test? And so we made it possible to use our product for that as well. And so the way we see it is once you have automated API specs, you can diff anything against anything. You can automatically identify breaking changes. And then the next thing that we're rolling out after all this is once you have specs, you can also automatically test. And if that's something you're interested in, I'd love to talk more about that as well. And I'm out of time, but really quickly, here is what you would get on your GitHub. So when you add the endpoint, you'll actually get a really nice little summary right now, one endpoint added, and then one new data format added. And then you can click into all of the reports. So thank you guys for attending the talk. I'll hang around in the chat for a little bit if you have questions. We are in a private beta, so do sign up if this sounds cool to you. And talk to me on Twitter. Feel free to email me, get in touch if you have comments, questions, feedback. Thank you.